So before, when we were testing scientifically hip hop, I was looking at what was a continuous error function. And what happens is that you see this point right here. Um, it's on a 2D axis. So you have a non-random error. And so this is actually right here. And it's represented by a matched pair with with the same distance going to and fro, x and y. And so you see all these points here. So you have B and B, H and H, P and P, VP, VS, G and G. So it just so happens that these are some of the outputs that are coming on the surface of a function that lie on a function and that are basically random errors, or um, we're testing epsilon and seeing if the error output is showing a pattern to see if this function is real. And this is the f of two functions. I mean, it could have been an exponential function, but it wasn't necessarily an exponential function. But before, I mean, we're testing a null equation, so f of n to 0. And the point is that once you reach that error output, you can actually test the equation on a linear axis. So it's a continuous random error, or non-random. It's a continuous error function, and it's a random output, or non-random in this case. And what we see is essentially all of the activity of the bandwidth where we're at here. So all of the wave function can be a bandwidth, and it's oscillating in between one level and another. The continuous error being in this case 8787 and 87. So it's basically ending. We know that it's going to end at 7. So that's the beauty of this mathematical error. So that's the point, is that we have a bandwidth that is going from 7 to 8, 7 to 8. And then we can also test the linear function. We can test it on linear axis for once we're contained at this point right here. We have all these different things going on. We have all these outputs going on live. So we have, for instance, 2, 2, 8, 8, which is BB, HH, PP, VP, VS. And so all these are generating an output that contain a value. But the point is that they appear all on this scale, on this map. So once we're able to contain a certain level, a certain bandwidth, right? So that's where we get the information that we want with regards to the brainwave function, which is represented by alpha, beta, delta, gamma, and theta. So that is basically giving us beta being the fastest frequency, the most common frequency, and the delta being the frequency that is giving us the deep state of a dreamless state. So the things that we're thinking about that are non-random at this point, that are an error but non-random, is interesting, because what we can see now is something that is kind of neurological deep state. And so what I'm trying to posit or assert is that the messages that we receive, especially when they're coded messages, are like neurotransmitters that are functioning as neurologically that can be messaging our brains in a neurological way. So for this instance, once we reach RG, because for whatever reason we see that on a different function that delta, we want delta on RG, because for whatever reason I felt that was what I was trying to hinge on. And so what I see there is basically on the, let's see, so on the F, BHP F, the what I do is I'm testing the random outputs. I'm testing the random outputs based on location. It doesn't necessarily have to do with location per se. You're not pinpointing location per se. It's uncontained. So what I'm getting here is a transmitted message. Like, for instance, in one location, I'm getting a beautiful runner here. So I'm getting an actual value because I'm able to, I'm locking in on RG. Once I'm pinpointing on RG, I want to get my delta value, which has nothing to do with the brainwave delta per se. So what we see here is that the value of being at RG is that in one location I got beautiful runner, so I'm actually at BR, right? And then and then another location, I got Turk. So like that's the output that I'm getting once I'm locked in on RG. So that can be difficult because of course RG is a variable as well. And then I test it again and I'm getting something different, so telling me that there's volatility there. I'm getting dancer value for this location here. So that's telling me that's probably not the lock. That's probably not a lock step. And then for this location here, I'm getting real Turk. So I'm getting RT. So that would be RT, basically off the map here. So that is what I was doing, live testing epsilon on one-dimensional x-axis for the null hypothesis, f of n at HH. So like that was different. So I was getting live feedback at HH. Scientifically hip hop. If you haven't seen it, it's really not much. I didn't get most of the action on YouTube, but it was live, and so I just didn't capture it on YouTube. But if you want to check it out, you can. And then yeah, so what you do is you have to generate a bandwidth, and then you can do anything with a function and you're parsing it. So you can actually have real globe, real gay, real what's it gonna be for gay? I don't know. But real good or real God, So what you're doing is you're functioning. You're parsing the function so that you have to basically you got 5 decimal places here. So so the beauty of the continuous error is that you're always going to get 878787. So you can continuously reloop the function. So so you can get real good, and that kind of thing is different. So that's different, and then it's going to come down to a value. So these are the values that act as what I'm asserting. I haven't really proven this, but like B runner and Turk is basically coming down to a real value as a neurotransmitter.